now we'll see the overview concept in motion planning. Okay, so overview concept in the sense the motion planning, it depends upon the problem which it solves, the robot, where it is implemented, right? What is the application? What is the environment? Everything is very important to design a motion planner. Okay, for that the 4 important tasks is navigation, coverage, localization and mapping. This is very important. Okay, so for any motion planner these 4 tasks is very important. So what is navigation? It deals about the problem to find out the collision free path for the robot, right? That is called navigation. Okay, so எந்த ஒரு collision இல்லாம collision free path கண்டுபிடிக்கிறது தான் வந்து navigation task. And what is coverage task? As I said, it has to move the sensor or the tools in such a way that it covers the entire surface, right? That is called as coverage. The problem deals with that is called as coverage. And localization in the sense the robot has to be intercept with the sensor data. It has to intercept the sensor data with the map so that it can able to identify the exact localization of that particular robot, the location of that particular robot, right? And then the last one is mapping. Mapping is something navigation to an unknown environment, right? So these are the 4 important tasks, and you can see here, as I said, navigation is the problem to find out collision free motion, and coverage is passing a sensor tool to cover the entire surface, and localization is using a map to intercept the sensor data to configure the robot, right? To find the exact location of it, right? And mapping is exploring an unknown environments. Okay, exploring the environment, navigating through it. Like in the sense, what mapping will do is it can create a representation which can be used for all these 3 tasks. Okay, by going to an unknown environment, it can create a representation which can be useful for all these 3 tasks. Okay, and now we'll see about the properties of robot. You got to understand only 2 properties, that is 2 different types of robots, right? As I said before, for motion planning, the robot application and implementation, that is very important, right? The environment where it is implemented. Okay, so if the robot is can able to move in any direction without any restriction, if you can able to move in any direction, that particular robot is omnidirectional robot, right? And if there is any constraints, like if that particular robot cannot move in this side direction or that side direction, or if it has any velocity constraint, it cannot move fast or slow, something like that. For example, you cannot translate the car in this way, right? Sideways. You cannot move the car sideways, right? So similarly, if you have any such constraint, that particular robot is non-holonomic robot. If there is no constraint and if you can able to move in any direction, it is called omnidirectional robot. And if there is any constraint for that particular robot, then it is called as non-holonomic robot. Okay, and you have to understand, in order to make a robot to move, it is not just a simple task. For example, any particular action which is done physically, any movement action, you'll have number of things, like you'll have a lot of physics involved in it, lot of motion theory involved in it, lot of dynamics involved in it, lot of computational factors involved in it, right? So in order to design a complete planner, right, a robot can be modeled by using kinetic equations, velocity controls, dynamic equations, and lot of other computational theories as well. Okay, and you will see about the properties of algorithm. The algorithm is something which you mention as planner. இப்போ நமக்கு தெரியும் பிளானர் என்னன்னு தெரியும், ரைட்? அது ரோபோட் எப்படி மூவ் பண்றதுன்னு தெரியும். ஆனா அந்த பிளானரை நம்ம இவ்வளவு டிசைன் பண்ணா கூட பிளானரை எக்ஸிக்யூட் பண்றதுல லாட் ஆஃப் பாராமீட்டர்ஸ் இருக்கும், கரெக்டா? ரைட், பிளானர் எக்ஸிக்யூட் பண்ணணும் அப்படின்னு பாத்தீங்க அப்படின்னா it has to execute very fast and it has to be very accurate. The time it takes, that is very important, right? Even after executing it, what is the memory that is needed for that particular algorithm? All this comes into the picture. Okay, for that, even for that, like the properties of algorithm is very, very important. Okay, what is the properties of algorithm? There can be a planner, there can be an algorithm which can provide solution for any problem. ஒரு robot move ஆயிட்டு இருக்கு, அதுக்கு ஒரு பெரிய obstacle இருக்கு அப்படின்னா, அதுவே அந்த அல்காரிதம் என்ன பண்ணும் அப்படின்னு பாத்தீங்க அப்படின்னா, அந்த ப்ராப்ளத்தை ஓவர் கம் பண்றதுக்கு it can provide solution, the complete solution, right? It can face any particular situation, and if you can able to provide solution for it, that algorithm is called as complete algorithm. We don't need any external informations, which is already been, it can be already be designed in such a way that it can face any situation and it can provide solution in a complete way, right? That algorithm is called as complete, right? But as I said before, as the degrees of freedom, DOF increases, lot of parameters has to be considered. Okay, so designing a complete algorithm may not be possible all the time. Okay, in that case we don't need a completeness of the algorithm, but there can be some weakness in that completeness. Okay, you got to understand what I'm saying. Okay, see, the reason why I'm speaking only in English is because a lot of other state students also involved, seeing these videos and all those things. Okay, and right now I'm working in a university where you have a lot of other state students as well, and that is the only reason why I am speaking only in English. Okay, and I'm sure that you can understand. Then and then நான் தமிழ்லயே சொல்றேன் so that you can get it. Okay, so degree of freedom ஏற்கனவே நான் சொன்னது வந்து பாத்தீங்க அப்படின்னா, degree of freedom is lot of parameters involved. Okay, if lot of parameters involved, then complexity of the algorithm is increasing. If complexity increases, complete solution not possible. ஆனா அதுக்கு கொஞ்சம் கம்மியா ஒரு weakness இருக்கும், சரியா? அந்த weakness தான் என்ன சொல்லணும்னா some weakness, right? So it cannot be a complete solution, but there can be a weakness in that completeness. Okay, அந்த weaknessலயுமே பாத்தீங்கன்னா ரெண்டு type of weakness இருக்கு. ஒன்னு வந்து பாத்தீங்கன்னா resolution completeness, right? Resolution complete in the sense the planner can able to give solution only at one particular resolution. ஏதா ஒரு particular configurationல ஒரு particular resolutionல அதால solution கொடுக்க முடியும். That is called as resolution completeness. Another weakness என்ன சொல்லலாம் அப்படினு பாத்தீங்கன்னா probabilistic completeness அப்படினு சொல்லலாம். That is, it can able to provide solution, right? At least one solution. எவ்வளவு நேரம் ஆனாலும் சரி, right? எத்தனை தடவை நீ ட்ரை பண்ணாலும் சரி, ஒரே ஒரு சொல்யூஷன் அது எப்படியாவது கொடுக்க முடியும். That is called as probabilistic completeness, right? இது தெளிவா சொல்றேன், நல்லா புரிஞ்சுக்கோ, right? எந்த ஒரு எக்ஸ்டர்னல் இன்ஸ்ட்ரக்ஷனும் இல்லாம ஒரு டிசைன் பண்ண அல்காரிதம் ஆட்டோமேட்டிக்கா எல்லா ப்ராப்ளத்தையுமே அதுவே சால்வ் பண்ணுது. ஒரு அப்ஸ்டக்கிள பாக்குது, அதை எப்படி ஓவர் கம் பண்ண முடியும், அதுக்கான சொல்யூஷன் அதே பார்த்து மூவ் ஆச்சு அப்படின்னு பாத்தீங்கன்னா that is complete algorithm. Okay, but that complete algorithm is not possible if the degree of freedom increases. Okay, அப்போ அதுல கொஞ்சம் வீக்னஸ் வர வாய்ப்பு இருக்கு. அந்த வீக்னஸ்லயுமே வந்து weaker form of completeness அப்படின்னு சொல்லலாம், சரியா? சோ அப்போ அந்த weaker form of completenessல ரெண்டு டைப்ஸ் இருக்கு. ஒன்னு வந்து resolution completeness, another one is probabilistic completeness. Resolution completeness in the sense you can able to provide solution at one particular configuration or one particular resolution. Okay, and another is probabilistic completeness, which you can able to provide probabilistic solution at least one particular solution. If there is, right, it can provide at least one solution at any number of times. Okay, this is the properties of algorithm. Okay, and as we said before, and the planner வந்து offline planner இருக்கலாம். முன்னாடியே சொன்ன மாதிரி ஏற்கனவே டிசைன் பண்ண இன்ஸ்ட்ரக்ஷன்ஸ் ஆல்ரெடி ப்ரீ பிளான்டா அதுல இன்ஸ்ட்ரக்ஷன்ஸ் இருக்கும். ஏன்னா அப்ஸ்டக்கிள்ஸ் ஏற்கனவே தெரிஞ்சு இருந்துச்சு. all it does is it's executed plans, right? அப்புறம் இருந்துச்சுன்னா அது வந்து ஆஃப்லைன் பிளானர் அப்படின்னு சொல்லலாம். ஏன்னா அதுக்கு எதுவுமே புதுசா இப்ப பண்ணல, ஏற்கனவே ஃபீட் பண்ண இன்ஸ்ட்ரக்ஷன்ஸை எக்ஸிக்யூட் பண்ணி போயிட்டே இருக்கு, ரைட்டா? so that planner is called as offline planner. And there is another planner which is called an online planner. What is online planner in the sense? This is the realistic robots which we use right now, right? These robots can able to understand or execute the plans based upon the sensor information. Sensor based பண்ணி sensor கொடுத்த information based பண்ணி then and there அது வந்து பாத்தீங்கன்னா பிளான் பண்ணி போச்சு அப்படின்னா that is called as online planner. Okay, மூவ் ஆயிட்டே வருது. இப்போ இந்த இடத்துல obstacle இருக்கு அப்படின்னு பாத்தீங்கன்னா it senses there is an obstacle. So what it will do is it gives that information to the robot. So robot computes that particular information, and based on this sensor information it will take solution for it, right? That is called as online. On spot la it decides, right? And coming to this offline and online planner runs very quickly because it is already executed, it's already fixed. Okay, and online planner will take some time. Okay, and similarly we can able to make offline planner to work very efficiently by giving feedback loops based upon the movements, based upon the sensor data. You can able to give feedback loops for it. Okay, and as a whole, a planner system, a robotic system can be a feed forward control and feedback control. Feed forward na enna, feedback na enna உங்களுக்கு தெரிஞ்சிருக்கும், சரியா? The system can be a forward control or feedback control. Feed forward என்ன சார் நம்ம சொன்ன மாதிரி சென்சார் பேஸ்ட் எல்லாத்துக்குமே feed forward தான் தேவைப்படும். ரைட்டா? feed forward என்ன அர்த்தம் அப்படின்னு பாத்தீங்க அப்படின்னா based upon the prediction. ரைட்? இப்போ மூவ் ஆயிட்டே இருக்கு, அடுத்து என்ன நடக்கும், அடுத்து என்ன பண்ணணும், அடுத்து என்ன பண்ணணும் அப்படின்னு சொல்லி predict பண்ணிட்டு போயிட்டே இருக்கிறது. ரைட்? based upon that information it works out and it moves forward. That is called as feed forward control. And feedback control is nothing but it does not based upon prediction. Prediction based பண்ணி இருக்காது. It based upon the error. ரைட்டா? ஏற்கனவே முடிஞ்சிருக்கும், இது இங்க போனதுனால இங்க தப்பு நடந்திருக்கு, அப்போ அதை ஃபீட்பேக்கா கொடுத்து அதை மாத்திருக்கும், அப்போ இந்த சைட் போக கூடாது அந்த சைட் போகணும் அப்படின்னு ஃபீட்பேக் எரரை பேஸ் பண்ணி வர்றது அப்படின்னா that system is called as feedback control system. Okay, so today we have seen what is the importance of motion planning, robotics motion planning, and what are the applications of it, and what is the piano movers problem na enna, adoda variations enna appdi paathom, and 4 important tasks enna appdi paathom, and then properties of robot paathom, and properties of algorithm paathom, and last ah vandu feedback control appadina enna appdi paathom. Okay, so I believe this will be very useful for you, right? This is very interesting subject, and I'm sure most of the students will not be listening in the class, but definitely these videos will be very helpful when you are preparing for your exams. Okay, thank you students.
Thank you students, thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும் நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.